Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
This is SpaceTime Series 25, Episode 60, for broadcast on the 3rd of June 2022. Coming up on SpaceTime, strange new readings from the Voyager 1 spacecraft in interstellar space, Artemis 1 to return to the launch pad, and new satellite manufacturing hubs to be built in Sydney and Canberra. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
There's something mysterious happening with the Voyager 1 spacecraft, which is now traveling through interstellar space. While the probe continues to return science data and otherwise is operating normally, mission managers are searching for a source of a strange system data issue. The engineering team with NASA's Voyager 1 spacecraft are trying to solve the mystery. The spacecraft is operating, receiving, and executing commands quite normally. But readouts from the probe's attitude, articulation, and control system don't reflect what's actually happening on board. This system controls the 45-year-old spacecraft's orientation. Among other tasks, it keeps Voyager 1's high-gain antenna pointed precisely at the Earth, thereby enabling it to send and receive data. Now, all the signs suggest that it's still working, but the telemetry data it's returning is invalid. The data appears to be randomly generated, or at least it's not reflecting any possible state the equipment could be in. Interestingly, the issue hasn't triggered any on-board fault protection systems, which are designed to put the spacecraft into a safe mode, a state where only essential operations are carried out, thereby giving engineers time to diagnose an issue. And Voyager 1's signal hasn't weakened either, which suggests that the high-gain antenna remains in its prescribed orientation with the Earth. So, what to do? Well, mission managers will continue to monitor the signal closely as they continue to try and determine whether the invalid data is coming directly from the attitude, articulation, and control system or some other instrument involved in producing and sending telemetry data. Until the nature of this issue is better understood, mission managers can't anticipate whether or not it might affect how long the spacecraft can continue collecting and transmitting science data. Voyager 1 is currently 23.3 billion kilometers from the Earth. It takes some 20 hours and 33 minutes for radio signals traveling at the speed of light to cover that distance. So that means it takes roughly 2 Earth days to send a message to Voyager 1 and receive a response. It's the delay the mission team's well accustomed to. Voyager's 1 and 2 project manager, Susan Dodd from NASA's Jet Propulsion Laboratory in Pasadena, California, says a mystery like this is sort of par for the course at this stage of Voyager's mission. You got to remember, the spacecraft are both almost 45 years old, far beyond what mission planners anticipated. And they're also now both traveling through interstellar space, a high radiation environment that no spacecraft has ever flown in before. Dodd says if engineers can't find the source of the anomaly, mission managers will just need to adapt to it. If they do find the source, they may well be able to solve the issue through software changes, or potentially by using one of the spacecraft's redundant hardware systems. And that wouldn't be the first time the Voyager team have had to rely on backup hardware. Back in 2017, Voyager 1's primary thrusters showed signs of degradation, so engineers switched to another set of thrusters that had originally been only designed for use during the spacecraft's planetary encounters. And those thrusters worked fine, despite not having been used for 37 years. Voyager 1's twin, Voyager 2, is currently 19.5 billion kilometers from Earth and continues to operate nominally. Launched in 1977, both Voyagers have now operated far longer than mission planners had ever expected. And of course, they're the only spacecraft collecting data from interstellar space. The information they provide from this region has helped drive a deeper understanding of the heliosphere, the diffuse barrier the Sun creates around the planets in our solar system. Each spacecraft's now producing 4 fewer watts of electrical power a year, limiting the number of systems the craft can run. The mission engineering team have switched off various subsystems and heaters in order to reserve power for science instruments and critical systems. Luckily, no science instruments have been turned off yet as a result of the diminishing power availability. And the Voyager team are working to keep the 2 spacecraft operating and returning their unique science beyond 2025. While engineers continue to work at resolving the mystery the Voyager 1 mission has provided them, the mission's scientists are continuing to make the most of the data coming down the spacecraft's unique vantage point. The 2 Voyager spacecraft are leaving our solar system in different directions. In about 40,000 years from now, the Voyager 2 spacecraft will come within 1.7 light-years of the star Ross 248. Now, currently, this small red dwarf is about 10 light-years away, but within 40,000 years, it'll have moved to just 3 light-years from the Sun. That'll make it the closest star to our solar system. And a few hundred years later, Voyager 1 will come to within a similar distance of Gliese 445, another star currently 17 light-years away, but one which then will be within 3 light-years of the Sun. Sometime after this, Voyager 2 will come within 4 light-years of the star Sirius. It's the brightest star in our night sky. And 570,000 years from now, Voyager 1 will fly close to the stars GJ 686 and GJ 678. However, after that, it's difficult to say what will happen, and both are quite likely to change their direction quite considerably over the course of their journey. See, the biggest unknown is how many rogue planets are out there. These rogue planets could exert gravitational pulls and pushes and completely change where the Voyagers end up going. Sadly, of course, we'll lose contact with both probes much sooner than that, in the coming decade in fact, and so it's unlikely we'll ever know what's happened to them beyond then. This is SpaceTime. Still to come, NASA's Artemis 1 moon rocket about to return to the launch pad, and new satellite manufacturing hubs to be built in Sydney and Canberra. All that and more still to come on SpaceTime. Okay, let's take a break from our show for a word from our sponsor, NordVPN. We've been using NordVPN for ages because it works brilliantly. It's fast, it's reliable. In fact, there are times when going online through NordVPN is actually quicker than through our regular connection. And of course, having a virtual private network's really important these days, all the nasties out there online. NordVPN helps keep you and your family safe from hackers, especially when you're using public Wi-Fi. You got to remember, public Wi-Fi really is a hacker's playground, and it's been proven time and time again not to be secure. Their encryption standards simply are not up to the levels required today, and they can be easily overcome by any expert hacker. But never fear, NordVPN's here, and it's got you covered for not very much money. In fact, you can set it up on your phone, your tablet, your PC, your TV, your laptop, in fact, anything that connects to the internet. It's a great way to help secure you and your data. And to make life easy, you can even set it up to turn itself on when you turn your device on. You don't even have to think about it. And now would be a great time to check out NordVPN because we have a special exclusive offer for SpaceTime listeners. Just go to nordvpn.com/StuartGary and use the code Stuart at the checkout to get a huge discount on your VPN plan. Plus, we'll give you an additional month for free and free anti-malware. And it's all completely risk-free as it comes with a 30-day money-back guarantee. So, what have you got to lose? Simply cancel and it won't cost you a thing. And there's a lot more to NordVPN than simply protecting you from hackers, although that's a very big thing in itself. You can read all about the multitude of benefits by visiting the website. So grab your exclusive NordVPN deal today by going to nordvpn.com/StuartGary and use the code Stuart to get the discounts and benefits, plus an additional month for free and free anti-malware. And as we said before, it all comes with a 30-day money-back guarantee, so you've got nothing to lose.
so give NordVPN a try. We've included the links in the show notes and on our website. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
NASA are looking at rolling the giant Artemis 1 SLS-Space Launch System Moon rocket and its Orion spacecraft out of the Vehicle Assembly Building and back to Launch Complex 39B at the Kennedy Space Center in Florida later this month for another attempt at a wet dress rehearsal. The test is designed to demonstrate that the giant 98-meter-tall rocket can safely be loaded with propellant and oxidizer and can carry out a liftoff or launch abort. Previous wet dress rehearsals back in April were aborted following a series of issues with ground equipment on the mobile launch pads, including valve, fueling, and leak issues. Engineers were able to quickly address the liquid hydrogen system leak in the tail service mask umbilical, which is located on the mobile launcher, which is connected to the core stage. It's common to see no leaks in normal air temperature, but then develop them at cryogenic temperatures. They also replaced the interim cryogenic propulsion stage gaseous helium system check valve and its support hardware, modifying the umbilical purge boots. The purge boots enclose an area around the interim cryogenic propulsion stage umbilical, the connection between the mobile launcher and the upper stage, to protect it from the environment during propellant loading. They found a small piece of rubber was preventing the valve from seating correctly. Now, there's nothing wrong with the valve itself, but mission managers would like to know where this rubber came from. They also confirmed there were no issues with the Orion spacecraft due to storms and heavy rains, which deluged the Cape Canaveral Launch Complex during the April test. The team also updated software to address issues encountered during core stage cryogenic tanking of both the liquid hydrogen and liquid oxygen during the April test. Meanwhile, contractors looking after the gaseous nitrogen system have completed their repairs and upgrades. The nitrogen is used to purge the rocket, including its umbilical plates. But the SLS is so huge, it needs more gaseous nitrogen, and the existing system was finding it difficult to meet the demand, so extra capacity has been added. Engineers have also undertaken some of the forward work originally slated to take place in the Vehicle Assembly Building following the wet dress rehearsal. This includes installing hardware elements for the Callisto technology demonstration, a flight kit locker, and assemblies for a space biology experiment. Once these are completed and verified, work platforms inside the Vehicle Assembly Building will be retracted, and the SLS and Orion will once again roll out onto Pad 39B for another dress rehearsal attempt, about 2 weeks after the mobile launcher Erector arrives at the pad. Now, if all goes well this time round, Artemis 1 will blast off in August on its maiden voyage, a 25-day unmanned test flight, taking it some 65,000 kilometres beyond the Moon in retrograde orbit. The mission will carry several experimental payloads aboard the Orion capsule, and it will deploy 13 6-unit CubeSats along the way before returning to Earth and splashing down in the North Pacific Ocean. If the mission goes as planned, Artemis 2 will launch in 2024, carrying the first manned Orion capsule on a 10-day mission around the Moon and back. That would be followed a year later by Artemis 3, which would then return humans to the lunar surface on a 30-day mission, something which hasn't happened since 1972. This is SpaceTime. Still to come, new satellite manufacturing hubs to be built in Sydney and Canberra, the bloated aging red giant Arcturus, the red supergiant Antares, and the June solstice are among the highlights in the night skies on June Skywatch. Plans have been announced for 2 new satellite manufacturing facilities in Sydney and Canberra. The $71.4 million project will develop 500-kilogram Earth observation satellites as part of plans to improve sovereign spacecraft production. Initial plans will see the manufacture of a constellation of satellites for the Australian government. The project will be jointly led by EOS Space Systems, which provides space debris and satellite management solutions, and Nova Communication Systems. One of the new plants will be built at the University of Technology Tech Lab in Sydney, with the other being located at the South Jerrabomberra Innovation Precinct outside Canberra. As well as the larger spacecraft, the project will also support the development of new nano and small satellites. The facilities will develop and produce their own propellants and fuels, as well as payloads, sensors, solar panels, structural components, optics, new space-related technologies and materials, optical wireless communication technologies, and key ground segment subsystems. The facilities are expected to create around 500 direct and indirect jobs over 5 years. They'll complement the new Australian Space Park now being built in Adelaide, which will focus on manufacturing smaller satellites such as nanosats and CubeSats. This is SpaceTime.
And time now to check out the night skies of June on Skywatch. June is the 4th month of the old Roman calendar and is named after Juno, who was the wife of Jupiter and also the equivalent to the Greek goddess Hera. Another belief is that the month's name actually comes from the Latin word junores, which means younger ones. June is a great time to look up at the night skies and marvel at the majesty of the Milky Way, which puts on a spectacular overhead display this time of year.
June also marks the winter solstice in the Southern Hemisphere, which this year happens at 19:13 Australian Eastern Standard Time on the evening of Tuesday, June the 21st. That's 9:13 in the morning Greenwich Mean Time and 5:13 a.m. US Eastern Daylight Time. Here in the Southern Hemisphere, it's the time of the winter solstice, and of course it means the arrival of summer for our lucky listeners north of the equator. The June solstice occurs when the sun reaches its most northerly point in the sky as seen from Earth, zenith appearing to be directly over the Tropic of Cancer. Contrary to popular belief that the seasons on Earth occur when the Earth's orbit around the sun is at its nearest or furthest points, they're actually governed by the tilt of Earth's axis as it journeys around the sun in a year. So on the day of the June solstice, the Earth's south pole is tilted by 23.5 degrees away from the sun. The sun rises north of east and sets north of west. 6 months later, when the south pole is tilted towards the sun, it's the southern hemisphere summer. And in between, we have the autumn and spring equinoxes. Almost overhead this time of year, we have the constellation Virgo. The constellation is named after Virgo, the goddess of justice and the harvest in ancient Greek mythology, who used her scales to weigh good and evil. However, she became so disenchanted with the evil deeds of men, she threw away her scales and retreated to the heavens. Interestingly, the ancient Egyptians also associated Virgo with agriculture. There she was the goddess Isis, who sprinkled the heads of wheat across the sky, forming the Milky Way. To science, Virgo is a tightly packed region of space containing some 2,000 galaxies, all gravitationally bound into a gigantic galaxy cluster, located some 60 million light-years away, of which our local group of galaxies is simply an outlying member. A light-year is 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit of the universe. The mass of the Virgo supercluster is so enormous that its gravity generates the so-called Virgo-centric flow, causing our Milky Way galaxy, as well as Andromeda and all the other members of our local group, to move towards the supercluster at around 400 kilometres per second. That's despite the accelerated expansion of the universe over cosmic timescales. The Virgo supercluster is now thought to be nothing more than a lobe of an even bigger galaxy supercluster known as Laniakea, the centre of which is known as the Great Attractor. Laniakea and the Great Attractor are among the largest known structures in the universe. Despite the Virgo cluster size, it's so far away it's difficult to see without a decent-sized backyard telescope. You'll want something at least 100 millimeters in diameter or larger. Located right next to Virgo and directly overhead this time of year is the constellation Corvus the Crow. Greek mythology tells us Corvus could talk to humans, but he was a lazy bird. And so Apollo took away his ability to speak and banished him to the heavens. One of the highlights in the constellations Virgo and Corvus is the spectacular Sombrero galaxy M104.
Visible with a good pair of binoculars or a small telescope, this stunning spiral galaxy is seen almost edge-on, providing a spectacular backlit view of its galactic bulge stars and the molecular gas and dust lanes in its arms. M104 is located some 31 million light-years away, and is moving away from the Milky Way at about 1,000 kilometers per second. The Sombrero Galaxy has a diameter of about 50,000 light-years. That's about 30% the size of our own galaxy, the Milky Way. It's surrounded by up to 2,000 globular clusters, and an active central supermassive black hole at least 1 billion times the mass of our Sun. Now, by comparison, Sagittarius A star, that's the supermassive black hole at the center of the Milky Way, has just 4.3 million times the mass of the Sun. Globular clusters are tight balls containing millions of stars, which were all either originally formed at the same time from the same collapsing molecular gas and dust cloud, or they're the surviving cores of small galaxies that have been cannibalized by larger ones. By the way, the brightest star in Virgo is Spica, a spectroscopic binary located some 250 light-years away. Spectroscopic binaries are double star systems orbiting so close to each other or at such an angle that they can't be visually separated, at least not from our viewpoint on Earth. Under these conditions, their spectrum will actually be a combination of the spectra of both of the stars in the system. But as these stars orbit each other, one of the stars will be moving sort of towards us, the other will be moving sort of away from us. So, the star moving towards us will have a spectra that will be slightly blue shifted into high frequencies, shorter wavelengths, while the star moving away from us will have its spectra slightly red shifted to lower frequencies, longer wavelengths. And so the two stars in the system can be separated by their Doppler shift. Looking about 20 degrees above the western horizon in the early evening is the fourth brightest celestial object in the sky, the dog star Sirius. Only the Sun, the Moon, and the planet Venus look brighter. To the northwest or right of Sirius is another fairly bright star called Procyon, the brightest star in the constellation Canis Minor, the Lesser Dog. In Greek mythology, Canis Minor and Canis Major were Orion's hunting dogs. Procyon is a binary star system comprising a spectrotype F main sequence white star, Procyon A, and a faint white dwarf companion, Procyon B. Main sequence stars are those undergoing hydrogen fusion into helium in their cores. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectrotype O blue stars. They're followed by spectrotype B blue-white stars, then spectrotype A white stars, spectrotype F whitish-yellow stars, spectrotype G yellow stars, that's where our Sun fits in, spectrotype K orange stars, and then the coolest and least massive of all stars are spectrotype M red stars, commonly referred to as red dwarfs. Each spectral classification is also subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a G2V or G25 yellow dwarf star. Also included in the classification system are spectral types L, T, and Y, which are assigned to failed stars known as brown dwarfs, some of which were actually born as spectrotype M red dwarf stars, but became brown dwarfs after losing enough of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectrotype M red dwarf stars, which are around 75 to 80 times the mass of Jupiter, or 0.08 solar masses. The white dwarf Procyon B has about 0.6 times the mass of the Sun and a diameter of about 8,600 kilometers. A white dwarf is the stellar corpse of a Sun-like star. Having used up its nuclear fuel supply, fusing hydrogen into helium in the main sequence, it then expands into a red giant and begins fusing helium into carbon and oxygen. Stars like our Sun aren't massive enough to fuse carbon and oxygen into heavier elements, and so they turn off. Their outer gaseous envelopes float off into space as spectacular objects called planetary nebulae. What's left behind is a super-dense white-hot stellar core about the size of the Earth called a white dwarf, which will slowly cool over the eons of time. Located about 11.6 light-years away, Procyon A has about 1.5 times the mass of the Sun and about twice its radius. It also has about 7 times the Sun's luminosity, making it unusually bright for a star of this type. And that suggests that it started to evolve off the main sequence after having fused nearly all of its core hydrogen into helium. It means the star is about to expand into a subgiant as it begins fusing core helium into carbon and oxygen and burning hydrogen in its outer shell. As it continues to expand, the star will eventually swell to somewhere between 80 and 150 times its current diameter. It'll then become a red giant. This will probably happen within the next 10 to 100 million years. The blink of an eye in astronomical terms. The two stars, Procyon A and B, orbit each other every 40.82 Earth years at an average distance of 15 astronomical units, about the distance of Uranus's orbit around the Sun. An astronomical unit is the average distance between the Earth and the Sun, which is about 150 million kilometres or 8.3 light minutes. Looking to the north-northwest now, and you'll see the constellation Leo the Lion, looking like a bunch of stars shaped like an upside-down question mark. Located just 36.7 light-years away in the constellation Bootes the Herdsman is Arcturus, a bloated, aging red giant, about 7.1 billion years old, and nearing the end of its life. Having used up all its core hydrogen, it's now fusing helium into carbon and oxygen. That's caused the star, which is only slightly more massive than the Sun, to expand outwards to around 25 times the Sun's diameter, and become about 170 times as luminous. It'll soon puff off its outer gaseous envelope as a planetary nebula, in the process revealing its white-hot stellar core. In Greek mythology, Arcturus was the guardian of the bear. Now this is a reference to being next to the constellations Ursa Major and Ursa Minor, the greater and lesser bears. There's some indications that Arcturus could have a binary stellar companion, but the results remain inconclusive, at least for now. There's also speculation that it could have a large planet or substellar object orbiting it, something about 12 Jupiter masses in size, but again the research remains inconclusive. Looking to the east, and you'll see the three brightest stars in the constellation of Libra, the scales of justice, are visible about halfway, about 40 degrees above the horizon. These also represent the claws of Scorpius the Scorpion, which is chasing Orion across the sky. The brightest star in the constellation Scorpius is Alpha Scorpii or Antares, the Scorpion's heart. Easily seen with the unaided eye, this red supergiant is some 550 light-years away, and it's one of the largest known stars in the universe. Antares has about 18 times the mass and an incredible 883 times the diameter of the Sun. And it's about 10,000 times more luminous than our Sun too. Okay, turning to the southeast now, and there you'll see the constellation Sagittarius, the Archer. It's important because it marks the direction to the centre of our galaxy, the Milky Way. And of course, located some 27,000 light-years away in that direction is the galaxy's central supermassive black hole, Sagittarius A star. To the ancient Babylonians, Sagittarius was the god Nergal, the centaur, a creature half man and half horse. By the time Greek mythology took over, Sagittarius was carrying a bow loaded with an arrow and pointing directly towards Antares, the heart of Scorpius the Scorpion. The centre of the Milky Way and its supermassive black hole Sagittarius A star lie in the westernmost part of Sagittarius. The brightest star in Sagittarius is Epsilon Sagittarii, or Cors Australis, the southern part of the bow. Epsilon Sagittarii is a binary system located 143 light-years away. The primary star is an evolved spectral type E blue giant at the end of its life on the main sequence. It is about 3.5 times the Sun's mass and about 7 times its radius, and is radiating around 363 times the Sun's luminosity. It's also a very strong X-ray source, and is spinning very rapidly, with an estimated radial velocity of some 236 kilometers per second. The system also displays an excess of infrared radiation emissions, suggesting the presence of a circumstellar disk of dust. Now, the second star in the system appears to be inside this debris disk. Astronomers think it's a spectral type G yellow dwarf star with about 95% the mass of the Sun. The second brightest star in Sagittarius is Sigma Sagittarii or Nunki. The name Nunki is Babylonian, however its meanings are unknown. It's thought to represent the ancient Babylonian sacred city of Urdu on the Euphrates River. Now, if correct, that would make Nunki the oldest known star name in current use. Nunki is a spectral type B blue star, located about 260 light-years away. It has about 8 times the Sun's mass, 4.5 times its radius, and about 3,300 times the Sun's luminosity. Alpha Sagittarii or Ruckbat, meaning the archer's knee, is a spectral type B blue star. Located some 182 light-years away, it has some 2.5 times the diameter of the Sun and about 40 times the Sun's luminosity. Astronomers think it's surrounded by a dense debris disk and a newborn companion star, which is only now about to join the main sequence. The Sagittarius constellation also hosts many star clusters and nebulae, including some of the best-known astronomical objects in the sky. These include the Lagoon Nebula Messier 8, a spectacular pink emission nebula located 5,000 light-years away and measuring some 140 light-years by 60 light-years across. The central region of the Lagoon Nebula is also known as the Hourglass Nebula because of its distinctive shape caused by matter propelled by a massive star-forming region called Herschel 36, one of the few star-forming nebulae that it's possible to see with the unaided eye. The Lagoon Nebula was instrumental in the discovery of Bok globules, more than 17,000 of which have been found in the nebula. Astronomers think Bok globules contain embryonic protostars destined to eventually become new stellar generations. Also located in this region of space is the stunning Messier 17, better known to pretty well everyone as the Horsehead Nebula. It's located some 4,890 light-years away and is a dense region of ionized atomic hydrogen. Also known as the Omega or Swan Nebula, it spans some 15 light-years across and has about 800 times the mass of the Sun. It's considered one of the brightest and most massive star-forming regions in our galaxy, with a geometry similar to the Orion Nebula, except that it's being viewed edge-on rather than face-on. The open star cluster NGC 6618 lies embedded in the nebulosity, and its gases cause the nebula to shine due to the intense radiation from its hot young stars. Open star clusters are loosely bound groups of stars, usually containing a few hundred to thousands. They're thought to have originally all been formed in the same molecular gas and dust cloud, but they're not as densely bound together as globular clusters. Open star clusters generally survive for a few 100 million years, with the most massive ones maybe surviving for a few billion. Now, by contrast, the more massive globular clusters exert such a strong gravitational attraction on their members they can survive for tens of billions of years or longer. The nebula is thought to contain up to 800 stars. More than 1,000 additional stars are also being formed in the surrounding molecular gas and dust clouds. It's also one of the youngest known clusters, with an age of just 1 million years. The cloud of interstellar material which formed the nebula is roughly 40 light-years in diameter, and it contains at least 30,000 solar masses. The Trifid Nebula Messier 20 is another large star-forming emission nebula containing many young hot stars. Located between 2,000 and 9,000 light-years away, the Trifid Nebula has a diameter of around 50 light-years. The outside of the Trifid is a bluish reflection nebula, while the inner region glows pink thanks to ionized hydrogen. There are also 2 dark bands dividing the Trifid Nebula into 3 regions or lobes. Hydrogen in the nebula is being ionized by a central triple star system which formed at the intersection of the 2 dark bands, creating its characteristic pink color. Another star-forming region in this part of the sky is NGC 6559, located some 5,000 light-years away and containing both red emission and blue reflection regions. Now, the grouping of these 3 nebulae, the Lagoon Nebula, the Trifid Nebula, and NGC 6559, is known as the Sagittarius Triplet. Another object worth looking out for is the Red Spider Nebula, NGC 6537. It's a planetary nebula about 8,000 light-years away. It has a prominent 2-lobed shape that could be due to a binary companion or simply magnetic fields, and it has a fascinating S-shaped symmetry, with the lobes opposite each other appearing similar. Again, this is believed to be due to the presence of a companion star to the central white dwarf. As for the central white dwarf, the remnant of the original star, it produces a powerful 10,000 degree hot, 3,000 km per second stellar wind, which is generating 100 billion kilometre high waves from supersonic shocks formed as the local gas is being compressed and heated in front of the rapidly expanding lobes. Atoms caught up in these shocks are radiating invisible light, giving the nebula its unique spider-like shape and also contributing to the nebula's expansion. The star at the centre of the Red Spider Nebula is surrounded by a dust shell, making its exact properties hard to determine. Its surface temperature is probably somewhere around 250,000 degrees, although a temperature of up to 500,000 degrees can't be ruled out, which would make it among the hottest white dwarf stars known. Now, looking directly south right now, you'll see the star Polaris Australis, or more accurately, Sigma Octantis. It's the nearest star to the southern celestial pole, and consequently the counterpart to the northern star Polaris. However, Sigma Octantis is far harder to see than Polaris because it's much fainter. Located some 270 light-years away, it's an orange giant reaching the end of its life. Now, turning to the southwest and just above the horizon, you'll see the star Canopus. It's the second brightest star in the night sky after Sirius. Canopus is located some 310 light-years away and is the brightest star in the constellation Carina the Keel. Canopus is a supergiant some 9 times the mass of the Sun and 71 times its diameter. The month of June also marks the first of 2 annual encounters with the Taurids meteor shower. The Taurids are generated as the Earth passes through the debris stream created by the comet 2P Encke, which itself could be part of a larger comet which broke apart about 20,000 to 30,000 years ago, most likely following numerous interactions with the powerful gravitational field of the planet Jupiter. As their name suggests, the Taurids' radiant, or apparent point of origin, is in the constellation Taurus the Bull. The Taurids meteor shower is made up of larger, more massive material. Think of pebbles instead of dust grains. Earth passes through this stream twice every year, once in June, then again in October, where it's called the Halloween fireballs. The Taurids releases material both by normal cometary activity and also occasionally by close encounters with the tidal gravitational force of the Earth and other planets. Now, all this combines to make the Taurid stream of material the largest in the inner solar system. And since the meteor stream is rather spread out in space, the Earth will take several weeks to pass through it, causing an extended period of meteor activity compared with the much smaller periods of activity for other meteor showers. Now, included in the Taurid stream is a denser flow of gravelly meteoroids called the Taurid swarm. It's thought to be a ribbon of rocks roughly 75 million kilometres wide by 150 kilometres across and held in orbit by Jupiter's gravity. Now, occasionally the Earth will pass through some of the larger meteoroids in the denser Taurid swarm, and that can make things rather interesting on Earth. In fact, one of the larger chunks of the Taurid swarm is now thought to have been the cause of the infamous Tunguska meteor event in the skies over Siberia on June 30th, 1908. The Tunguska event is now believed to have been the airburst of a 100-metre wide meteor over the Tunguska region of Russia, causing mass devastation and flattening more than 2,000 square kilometres of forest into matchsticks. In fact, the blast was so bright it lit up the skies in London a third of the way around the planet. Tunguska remains the largest known Earth impact event in recorded history. It was considered a 1-in-1,000-year event, assuming a random distribution of events over time. But new studies suggest the event may have been caused by a Taurid swarm meteor. And with Earth passing through the swarm periodically, it changes the odds significantly. Now, if this study is correct, the swarm heightens the possibility of a cluster of large impacts on Earth over a relatively short period of time. Further complicating matters, the June Taurids are actually seen as 2 separate showers. The southern Taurids are the ones associated with the comet 2P Encke, while the northern Taurids originate from the asteroid 2004 TG10, an eccentric kilometre-wide asteroid classified as a near-Earth object and a potentially hazardous asteroid of the Apollo group.
Jonathan Alley, the editor of Australian Sky and Telescope magazine, joins us now for the rest of our tour of the June night skies.
G'day, Stuart. Yeah, well, look, it's winter time where I am down here in the Southern Hemisphere in Australia, and it's cold this time of year, but it's a great time of year for stargazing because it's winter time, so the nights are longer. So you've got more time to get out there and have a look, particularly if there are clouds coming and going or weather coming and going. You've got an extra couple of hours in the night to make it worthwhile. So it's a good time of year for that if you want to get rugged up and go outside. And so if you do so, after it gets dark, after sunset, it's all got nice and dark, and you go out and you let your eyes get dark, adapted a bit, you should be able to see the Milky Way stretching all the way across the sky from the east to the west, or west to east, doesn't matter, one way or the other. And the Milky Way, of course, is our galaxy just seen from the inside. So we're about 2/3 of the way out from the centre of the galaxy out towards where the galaxy is getting thin. So when you're looking towards the centre of the galaxy, you see lots of stuff. And if you look up at right angles out of the galaxy, then you don't see quite so much. So we'll get into that in a sec. So if you do have a dark location and you've got some clear skies and an unobstructed southern horizon, have a look right down to the south, not too far above the horizon, and see if you can spot these two fuzzy patches. And these are the Magellanic Cloud galaxies. These are actually fairly sizable galaxies that are very close to our Milky Way, and they just look like very faint clouds. And sometimes even you can use what's called averted vision. Don't look directly at them. Look sort of at the side of your eye, because if you do that, then the light coming in hits the correct part of your retina for nighttime viewing, the more sensitive part of your retina that just sees in black and white, basically. If you look directly at it, then the light is hitting the part of your retina that's best for daylight and colour, but there's not a lot of colour around at night. So use averted vision, just sort of look out the side of your eye and you'll be able to see some fainter things. So these are the two galaxies down there. Up above them, probably about 2/3 of the way up from the horizon, and standing upright, you should see the Southern Cross. I'm talking about 7:30 at night during June. Southern Cross, you can't miss it. When most people go looking for the Southern Cross for the first time, actually, they think it's going to be something really big, really, really huge. But it's actually really, really small.
It's the smallest constellation.
It's the smallest constellation in area in the sky, and you can easily just put your hand out and cover it up. I mean, it's really, really tiny, but it's quite prominent. Once you get it and it clicks, then you'll never have any trouble again. Nearby, there's an informal grouping of stars called the False Cross, which is in exactly the same shape, but much, much bigger. Stars are spread further apart. And people often latch onto that one and think it's a Southern Cross, but in reality, not far away is the real Southern Cross. But it should be pretty easy to see this time of year because it's up nice and high, about 2/3 of the way up from the horizon, as I said. Going a bit further up from the horizon, in fact, right to overhead, we've got the mighty constellation Centaurus, which contains lots of great deep sky objects that you can make out, even with just a pair of binoculars, 7x50, that sort of thing, which is a common size of pair of binoculars, or 8x30s. You're not going to get a fantastic view of details and things, but you can see them. Deep sky objects, by the way, are things other than stars. So we're talking star clusters, nebulae, these sort of glowing clouds of gas and dust out there in space, and even other galaxies way beyond the Milky Way. You're not going to see them really with... actually, no, there is one in Centaurus that you will be able to just make out as a fuzzy blob with a pair of binoculars. In fact, you can make it out as a fuzzy blob, a very faint fuzzy blob, just with the naked eye. It just looks like a little fuzzy star. So see if you can try and spot that one. Over in the east, we've got Sagittarius coming up. It's already above the horizon this time of year, but it'll get low. As the night goes on, it'll get higher and higher. Now, when you look in this direction, you're looking towards the heart of our galaxy, straight into the middle of our galaxy. And that black hole that the scientists took a picture of only a few weeks ago, that's in that direction. So obviously you can't see it, but when you look in that direction, you know, wow, that's that thing.
And what did you think when you saw the first images of Sagittarius A star?
Well, my first thought was it just looked like the other one they'd done, which was the one in M87.
Yeah.
I mean, all black holes look the same, don't they? Yeah. No, it is actually an amazing feat to get that picture taken, because even though the previous one in the galaxy M87, that galaxy is a long, long way away, everything is bigger there. So for them to be able to do that with our galaxy and our black hole, even though it's closer, is actually very, very bit of nifty observational work. So, look, it's quite incredible, because I remember even only 30-odd years ago, we couldn't see anything in the middle of the galaxy. It was all hidden by gas and dust and star clouds and things, and there was just no real indication of what was there. And then with new technologies coming along and bigger telescopes, went from 4-metre diameter class telescopes up to 8-metre and bigger 10-metre ones. And that just gives you a lot more power to resolve and see finer detail. So what they're doing now, you just couldn't have done 30 years ago. So, I grew up in an era when we knew nothing about what was in the middle of the Milky Way, absolutely nothing. All we knew that there were lots and lots of stars, and they were getting sort of denser and denser towards the middle, and who knows what was in the middle. Some people suggest there might have been a black hole there, but now we've got the evidence for it, basically. There's the picture. So
that's the proof.
Yeah, fabulous bit of science. Yeah, fabulous bit of science, and I'm just going to marvel what astronomers find during the rest of the course of my lifetime. It's just going to be staggering, you know.
It's an exciting time to study astronomy, isn't it?
Well, it has been for some decades. I remember probably, it would have been late 90s. I did a survey, a poll of a lot of top astronomers, and I asked them, you know, what have been the big things over the previous 10 years at that stage, and they pointed to all sorts of different things. But a lot of them did say, even back then, we're going through a golden age of astronomy. And part of it is the bigger telescopes and the electronic cameras and things, but it's also the computing power because, the old days you didn't have computers or electronic cameras. They took photographs using glass plates or film, and there was a limit to what you could do with that. But now with these fantastic digital cameras that they use, like super sophisticated ones, and the processing power of the computers, they can do things that, you know, were just literally impossible before. So, yeah, we're going through a real golden age, and there's been a lot of investment, a lot of money poured into astronomy too, because it's just one of those good things to do for the human spirit. Plus, it does boost the economies through, you know, high-tech investment in computing and in all sorts of other ways. So, we are really going through a golden era and have been probably for 20-odd years. So, as I say, I just shudder to think what we're going to see in the next 20 years. I think we will be getting, and before 20 years is up, I think we'll be getting at least crude pictures of exoplanets, planets circling other stars. I'm pretty positive they'll work out a way to do that. And I remember talking to an astronomer 25 years ago saying, we'll never get that. We'll never get that. They're too far away, too small. But I think he'll be wrong, or he'll be shown to be wrong. And he'll be as delighted as I am, I'm sure. So, yeah, that black hole in the centre of our galaxy. So when you get out there and you get a star map or something, have a look at the star map in the centre pages of Australian Sky and Telescope magazine, and you'll be easily able to identify where Sagittarius is. And when you look in that direction, you will be able to think, that's where that black hole is, that picture I saw on the news. I think it's great to be able to connect something, a picture that you've seen, and just look in the direction of it in the sky. Even though you can't see it, you think it's out there. It's like when I look at Mars, I think, okay, that just looks like a little reddish star thing. But there are rovers trundling around on that little reddish star thing out there, millions and millions and millions of kilometres away. And it just makes it a bit more real, I think. And we're lucky to live in this age, this sort of space age, where there are little rovers and spacecraft and stuff out there. Because in previous generations, everything up there in the sky was not connected to Earth in any way. We were all part of the same solar system or same galaxy, but nothing from Earth had ever gone there. So there was just no connection. But now we live in an era of connection, and we just get pictures daily from other planets. I mean, it's just amazing. Just amazing. Anyway, that's my little enthusiasm for that topic. Where do we get up to? Sagittarius. Pontification, yes. So, okay, so we've got Sagittarius over there sort of coming up in the east. If we go around to the northern half of the sky, it looks a bit bare for us, at least from where I am this time. It looks a bit bare looking up to the north. There are actually some really good constellations there, and if you've got a telescope, you can see some really good things that you can't see with the naked eye. So it's not as bare as it seems. There is a nice bright star that you can see in the north from down south here. It's called Arcturus. About halfway up from the northern horizon. And there's another bright star, Spica, which is pretty much overhead from where I am. And these two stars are really interesting. Arcturus is a red giant star that's a couple of billion years older than our sun. The same mass as our sun, but because it's more mature and it's further along in its lifespan and its evolution, it has ballooned up to be about 25 times bigger than our sun, which is quite amazing to think about. I mean, our sun's about, 1.2 million kilometres across? This thing's 25 times bigger. And there are bigger stars out there than that. So that's pretty amazing when you look at the star Arcturus with the naked eye and you think that's 25 times bigger than our sun. So it must be awfully impressive if you're up close to it. The other star I mentioned, Spica, it's a binary star system. So you've got two stars orbiting around each other. And that's very common out there in space. But these two are so close to each other. They're orbiting around each other so close. Every 4 Earth days, in fact, they complete an orbit around each other. They're so close that their mutual gravitational pull, one on each on the other, has stretched each of them into an egg shape rather than the star being round. Can you imagine that? Imagine the gravitational field to stretch a star into an egg shape rather than just this big round ball. That is quite amazing. And to think that these two stars are just spinning around each other every 4 days, I say this, I've always said this stuff is better than science fiction. It's better than Star Wars. It's real stuff, so you don't even really need science fiction in some senses because the real stuff is even better. As the night goes on, all that stuff that we've been seeing, a lot of it's still going to stay there. But of course, as the Earth turns, things drop below the horizon in the west and things come up above the horizon in the east. So as the night goes on, we'll have the bright stars Vega and Altair appearing in the north. And down in the southeast, we've got a star called Achernar, which is a nice bright star. That's a good one to see. And the Milky Way, which was stretching from east to west across the sky at the beginning of the night, is now stretching north to south. So again, it hasn't moved, of course, it's just the Earth is rotating on its axis. So let's look at the planets now. Well, you need to be up in the morning to see the planets at the moment. So if you've ever wanted to spot Mercury, this is a good month to do so, in fact. And you can find Mercury above the eastern horizon before sunrise. But it's best to probably leave it for the second half of the month when it's a little bit higher up and the sky's still a little bit dark, from about the 15th onwards. Mercury's pretty easy to spot, but it just does look like a bright star. There's nothing really to say that it's a planet other than the fact that it moves from night to night in position. But you can see it out there in the second half of the month if you're up before dawn. The other bright planets, they're out there as well. If you take a look about mid-month, you'll find you'll have Mercury near the horizon, then much brighter Venus will be not too far above it and a bit to the left. Then there's a big gap further up and to the left until you come to Mars, which looks like a fairly bright reddish star, even though it's not a star. Then there's a short gap to very bright Jupiter, which at that time is going to be pretty much due north. So we're going from east around to north. Can't miss Jupiter, big and bright. And then there's another big gap stretching further around to the northwest, and then you get to Saturn. And Saturn, too, is nice and big and bright. So you should be able to see all those 5 planets in a row. So you've got Mercury, Venus, Mars, Jupiter, and Saturn in that order, going from just above the eastern horizon all the way around to the northwest. But probably the best thing to see this whole month comes right on at the beginning of the month. Jupiter and Mars are going to be right next to each other. Right next to each other. So it should be a pretty specky sight. Jupiter, big, bright, white light, and Mars, this dimmer, but still fairly bright, reddy, reddish, sort of orangey colour. They'll still stay close together for about a week or so as they start to move apart, and then eventually after about 8 or 9 days, they'll be sort of accelerating away from each other as it appears to be on the sky. They're actually, of course, nowhere near each other out there in space. It's just our changing line of sight effect as the Earth's orbiting around and they're in their own orbits doing their own thing, and things just line up that way. But pretty good to see. If you get a chance to see that, we've got some good weather. June the 1st, in fact, any time during the first week of June, they'll be pretty close together. And that, Stuart, is the sky for June.
That's Jonathan Ali, the editor of Australian Sky and Telescope magazine.
And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.